Hello everyone. Hope you all are fine. Let us start today's session. We have already learned that a continuous and closed path of an electric current is called an electric circuit. We have also learned that the flow of electric charges is called electric current. In our previous session, we learned about a simple electric circuit, which is a combination of a cell or a battery, a plug key, electrical components, and connecting wires. So, now we will learn some of the components which are used in electric circuit diagrams. You can refer to page number 203 in your textbook. Table number 12.1 shows us symbols of some commonly used components in electric diagrams. That means when we use electric circuit diagrams, these symbols we will make use of. So it is necessary for you all to remember the symbols. Let us see one by one. First, an electric cell. So the symbol is, it is represented by two vertical lines. One is bigger, another one is small. The bigger line shows positive terminal of a cell. The smaller line shows negative terminal of the cell. Second one is a battery or a combination of cells. I have already mentioned in a previous session that a cell is a single thing. When there is a battery, that means it is a combination of two or more cells. So here in the symbol also you can see it. There is a combination of three cells. So this way you will draw the symbol. Third is plug key or switch, which is open. Now look at the symbol, how it is shown, like a bracket, right? But when it is open, you will not keep any dot inside it. Fourth one is plug key or switch, which is closed. Now how it is? It is brackets and in between one small dot is there. This means it is closed. Remember this, when you draw circuit diagrams, this you need to keep in mind. When there is switch which is closed, you will keep dot in between. When it is open, you will not keep any dot in between. Fifth is a wire joint. So when it is a wire joint, it is connected by a dot, you can see. Sixth one is wires crossing without joining. So there are wires which are connected without joining. So this way you will show, like shown in the symbol for wires crossing without joining. Seventh is electric bulb. So when we draw circuit diagram like this, how it is shown in the textbook, that way we have to represent. Next is a resistor or of resistance R. So how it is shown in this symbol, that way you will write. Now there is a correction which you will make in your textbook. Look at the image which is displayed on the screen. There, for number 8, a resistor of resistance R, I have drawn a symbol. That way you will draw in your textbook also. This is a correction which you will make. Why is it so? I'll tell you. When we draw a resistor, from where it starts, on the opposite side it should end. That is why you will draw how I have drawn. It is displayed in the image. You will copy it in your textbook also. You will make correction. Number 9 is variable resistance or rheostat. So when there is rheostats, it is like a resistor only, but one arrow you have to keep it up. 10th number is ammeter, which is shown in the figure. how to draw ammeter when we draw circuit diagram. Remember what is ammeter? It is an instrument to measure electric current. Last is voltmeter. So this symbol you will use for drawing voltmeter in an electric circuit. These symbols you need to remember properly for drawing electric circuit diagrams. So this is all about circuit diagrams and the components which we use for drawing circuit diagrams. Now we are going to learn very important the law of Ohm. So let us find what it is. Before learning this Ohm's law, we have to perform activity. So you will refer to page number 203 and 204 for activity 12.1. We have to set a circuit shown as in the figure. So it is displayed on the screen. This way we have to make circuit. For that we need a nichrome wire of XY length. So in the figure you can see there are 2 points shown as X and Y. So that is of nichrome wire. We also have ammeter. Now you can see in the circuit ammeter is connected in the series. Remember to connect ammeter always in series. Then we have a voltmeter which is V. Then we have 4 cells. You can see above on the upper side, top side, there are 4 cells. That means it is a battery of 4 cells. Okay, now you will be thinking, what is this nichrome? So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Now you all know what is an alloy, right? In standard 9 we have already learned. It is a mixture of metals. So here nichrome is an alloy of nickel, chromium, manganese and iron metals. Now we have to connect all these components as shown in the figure. Then what do we have to do? First we have to use one cell. So as I told you that there are 4 cells. From that 4 cells, only one cell we have to use. So other 3 we have to remove. In place of cell, we will keep only one. Then we have to note the reading in ammeter. This means when we will keep one cell and this switch we will on, then there will be some readings shown in ammeter. Right, so we will note that reading. At the same time we have kept voltmeter, right, between 2 ends of wire. Which is that ends of wire? X and Y. And between we have kept voltmeter, so it will show reading in voltmeter also. So we have to note that readings. This way the table for readings is given. So in the first column serial number, second column number of cells used in the circuit, then it is current I, potential difference V, and then V divided by A. Now you see here second column, that is number of cells used in the circuit. Now see the first row in which 1 is written. This means when we are using one cell. So right now we are using one cell, so we will note reading for I, current, which will be shown in ammeter. Then we will note reading of voltmeter. And then we will find ratio of V divided by I. V is potential difference, I is electric current. Here I have noted some readings. So for first it is 1.5 I and V is 2.7. So I got V divided by A ratio as 0.55. Now next time what we have to do? We have to place two cells. Before we kept one cell, now we will use two cells. And the same way we have to switch on, then we have to note down the reading of electric current I, potential difference V. When we will find ratio of V divided by I, we will get 0.55. Next time, what do we have to do? In place of 2, we will add one more cell. So now we have 3 cells in the circuit. When we'll switch on, it will show reading in ammeter and voltmeter. So both the readings for electric current and potential difference, we will note it down. Then we will find ratio of V divided by I. And lastly, what do we have to do? All 4 cells together we will keep. And then we will note readings of electric current as well as potential difference through ammeter and voltmeter. And then we have to find V divided by I. Now, observation, you can see in the last column V divided by I, that is ratio of potential difference and electric current. Observe the values which we got. What it is? 0.55. In all observation, for all the readings, we got value as same, V divided by I. That is, here in this example, we got 0.55. These are the readings which are noted for some experiment that we are considering. So here we got value 0.55. You can see it is same for all the readings when we used one cell, when we used two, when we used three, and even when we used 4 cells together.